Tangent line, what do I need? And you need a point and a slope. I don't care what mode, if you want an equation of the tangent line, you need a point and a slope. And then you can plug both of those directly into point slope. Okay, first thing we need is what? What's the first thing we solve for? The point. Why the point? So you don't accidentally plug it in the wrong thing. We have our equation so we can directly plug in to solve for the point. At time equals -3. What's the point? Where are you? What's your x and y position? Yeah, you plug it -3 into here. 3 minus 3 is 0. There's your x position. What's your y position? -3 minus 1 is -4. There you are. I see you. You're right there. You see? Okay, so now I have my point. What's the next thing I need in order to file for equation of a tangent line? Slope. How do you usually solve for the slope? What do you do? In general, what do you do to find the slope of the tangent line? Yeah, or what? You take the what? Yeah, you take the derivative. If you want the slope of the tangent line, you take the derivative and plug in that x value. So I go, okay, change in y over change in x. And I say, uh-oh, whoa. I have a problem. What's my problem? Yeah, I have x in terms of t and y in terms of t, but no y in terms of x. So what can I do? There's two things you can do. 3. One is that. Solve for one equation in terms of t and plug it into the other. The second one, of course, is cry. And the third one is, yeah, you can break it up into the two different pieces. This, if you solve for dy over dt, which, can you do that? And then, is it multiply?
Divide.
Why is it divide?
Because you have dx over dt instead of dt over dx.
dy dt divided by dx dt, that would be the same as dy dt times dt over dx. And the dt's would cancel out, leaving you with dy dx. Okay, good. So I want dy, that'll work, dy dt over dx dt. Okay, now we're cooking with gas. Bubble. Let's find dy dt. What's the derivative of y in terms of t?
1.
dy dt. So you take the derivative of this, and you treat that t just like an x, and you get 1. Great, now we're cooking. This problem's easy.
No.
Dx dt, we take the derivative of this and... we got a problem, right? We don't know any rules for absolute value. Right? Does that make sense? What? Wow. Here's your rule. For positive times, you can just drop the symbols. You know what I'm saying? So that's not for this case. But if time is positive for t greater or equal to 0, this is your x equation. How do you take the absolute value of a -5? What do? You take the opposite of what's inside when it's negative. So you can drop the symbols and take the opposite of what's inside. And that's how you actually do an absolute value derivative. Okay? And does that make sense? That's why, well, check this out. That's why y equals absolute value of x. You take the opposite of what's inside for x less than 0. Derivative of this is -1. You just drop the symbols for x greater than or equal to 0, so x equals 1.